Mic test. Okay. For this video, focus tayo sa virial equation of state. Okay. Ito yung virial equation. Na-discuss na natin to sa earlier video natin. We can express the product of pressure times volume as a power equation. Of course, it can have an infinite number of terms. Okay, pero for practicality, we just truncate based sa number of terms na kailangan natin. Itong first equation, express siya in terms of pressure, but we can also express it in terms of temperature and volume. And these are what we call virial coefficients. Function siya ng temperature. And we can also express it yung right side equation na Z instead of P. So, yung kaninang equation, ito, dinivide lang yan ng, dinivide siya ng RT, minultiply siya ng V, para yun ay maging Z, diba? Naalala niyo, compressibility factor is PV over RT. And the equation, the virial equation, is transformed to this equation. Okay? So, yung mga constants natin, ginawa lang na instead of B, A, B, C, naging ano lang siya, yung B prime, C prime, D prime. Kasi ito yung gagamitin natin kapag in terms of ano tayo. I mean, we are expressing it, alternative expression, using Z or compressibility factor. Ibalik natin yung equation na instead of in terms of pressure, in terms of volume. Okay? So, ito, yung B prime, C prime, at saka yung B, C, D, virial coefficients din siya. O, katulad lang siya nung virial coefficients nung una nating equation. And again, same lang din in terms of, functions of temperature din siya. Okay. So, meron tayong, paano natin masosolve yung, coefficients? Okay. So, as you can observe dun sa equation kanina, yung B prime, it's just P over RT. And then, the rest, if we want to solve for C prime, ito lang yung equation niya. And then, for D prime, ito yung equation niya. So, may pattern, di ba? Yan. So, meron silang relationship. Yung C prime, may relationship yung B prime sa B, yung C prime sa C, and so on. Okay. So, maraming equation of state, diba? Maraming equation of state, mic test, ayan. Pero, yung virial equation lang yung pinaka-based sa statistical mechanics. So, pag sinabing statistical mechanics, diba, yung field of study na yun, based siya sa probability. And in fact, each term sa virial equation, meron siyang meaning, meron siyang interpretation, or, meron siyang representation. For example, yung first term nga ba to? B over V. Second term, okay. Yung second term na B over V, okay, kasi yung first term ay 1. So, yung second term na B over V, nagka-correspond siya sa amount of interaction between a pair of molecules. Okay, accounts for the interactions between the pair of molecules. The third term, yung C over V squared, accounts for the three-body interaction. Okay, na-imagine nyo, pag nag-collide yung dalawang molecule, so pair lang sila, ang nag-a-account doon ay yung B over V na term. Pero ang collision mo ay tatlo silang nag-collide sabay-sabay, ang nagka-account nun ay yung third term, which is yung C over V squared, and so forth. So, pag yung next term na, pag apat na sila, yun fourth term na ng Virial equation. Pero sa, in terms of probability, di ba mas madami yung two-body interaction. Yung two-body interaction, mas marami siya than the three-body interaction. And yung three-body interaction, mas mataas yung probability niya. Yun, mas mataas yung probability niya than the four-body interaction and so forth. So, ulit, yung two-body interaction, mas mataas yung probability niya sa three-body. Yung three-body, mas mataas yung probability niya sa four-body, and so on. So, ano ang relevance nito sa atin? Ibig sabihin, habang dumadagdag yung terms ng Virial equation, pataas ng pataas yung, yung terms, okay, yung contribution ng terms na nandun sa rightmost or yung higher ordered terms. Higher ordered kasi, di ba, yung V cube na sila and so on. Yung mga low, yung mas mababang order, yung lang raised to 1, raised to 2. So, yung higher order terms, yung contribution nila mas mababa. Pa-decrease ng pa-decrease habang tumataas yung order. Ayan. So, balikan natin tong compressibility chart. Yung Z nasa y-axis, yung pressure nasa x-axis. And, dito tayo mag-start dun sa Z equal to 1. Ano nga ulit ibig sabihin? Pag Z equal to 1, it behaves like an ideal gas. Okay? And, magbe-behave na ganon kapag, diba, pag low pressure. So, pag nandito sa region ng low pressure, nasa simula tayo ng pressure dito, nagbe-behave yung gas malapit sa 1 na Z. Z equal to 1. Now, all isotherms, so lahat to ang lines na yan ay isotherm. All isotherms originate at the value, so lahat sila nagmula sa Z equal to 1 at saka P equal to 0. So, wala, zero pressure, mababang pressure. And, ang observation, nearly straight sila. Nearly straight at low pressure, diba? Pag low pressure, straight ang shape nila. Okay, so these are different isotherms. Tapos, ano pa mapapansin ulit natin? Balikan natin yung previous lecture natin. Ito ay higher temperature na isotherm. So, di ba mas malapit siya sa 1, yung 1 na value ng C, kasi sinasabi natin, pag yung ideal gas nagbe-behave, ang gas nagbe-behave siya ideally pag higher temperature. So, yan, mataas siya. So, nandito lang siya sa bandang 1 na Z. Pero yung mga low temperature, ito mga negative 150 na, negative 100 degrees Fahrenheit na, ang layo niya na sa 1, nandito na siya, nagdi-dip sila, 'di ba? Okay. Yan. So, anong ibig sabihin nun? Pag dinifferentiate natin yung equation na to ng Virial equation, okay, differentiate natin with respect to P at constant temperature. So, we get, diba, pag dinifferentiate mo, 1, 0, and then pag itong B prime times P dinifferentiate mo, okay, with respect to P, may iwan yung constant, and so on and so forth. Okay. Now, pag dinifferentiate natin at the P equal to 0, ang magiging equation lang natin ay B, yung equal lang sa B prime. Okay? Therefore, itong equation ng tangent, equation ng tangent line ay z equal to 1 plus b prime. Diba, pag nagdi-differentiate tayo, nakuha natin yung equation ng tangent. A result also given by truncating equation 4-3 to 2 terms. Okay. A more common form of the truncated virial equation results from substitution of v prime using equation 4-5a. Okay. Therefore, yung equation kanina expresses a direct proportionality. Meron lang direct proportionality between Z and P and often applied to vapors at subcritical temperature. Pag sinabi nating subcritical temperature, yung term na sub, diba, below the critical. So, pag subcritical, below critical temperature, up to their saturation pressure. So, pwedeng i-apply yon yung subcritical pressure up to their saturation pressure. At higher temperature, it provides a reasonable approximation of gases up to a pressure of several bars, with the pressure range increasing as the temperature increases. So, yun yung applicability ng virial equation. So, nagtruncate to 2 terms for application at low pressures. So, pag low pressure, we can actually just use yung 2 terms na virial equation. And it may be at least as accurate. Okay, mas, yung 4-8, ay, balikan natin. Saan na si 4-8? At this one is may be accurate as itong 4-9. So, mas madaling gamitin yung 4-8, pero kasing accurate lang siya nung 4-9. Okay? So, nakuha yung derivation. Okay, sige, reviewin nyo na lang. So, nakuha, bakit ito nga pala nangyari? Yung, in-evaluate lang natin yung derivative na to. Sinubstitute na 0 yung P, so na-zero out na to. Yung terms na to, nakuha na lang yon yung B prime. So, yun yung slope. Okay? And then, ginawa siyang equation ng line. Yan. Ayan. Okay. Yan. The second virial coefficient B is substance dependent and a function of temperature. So, nagde-depend siya sa type of gas at saka sa temperature. And saan natin makukuha yung data? Experimental values are available for number of gases. Now, for pressures above the range of applicability of equation 8 but below the critical pressure, kasi sabi nga natin na yung two-term na virial equation may range of applicability lang siya, which is nandito sa slide na to. Yan, diba? Up to, yung pressure niya, several bars. Okay? Up to several bars lang. Okay? Tapos, dapat yung critical temperature mo below, yung temperature nung gas ay below the critical temperature. And up to, yung pressure naman, up to saturation pressure lang. So, yun lang application nung equation, yung two-term equation. So, if we want, for pressure above the range of applicability of equation 4-8, pero, yung critical pressure pa rin ay below pa rin tayo doon sa value na yon, mas magandang gamitin na yung virial equation na may 3 terms. So, instead of 2 terms, yung 3 terms na. Kasi, diba, sabi nga natin, mas madaming terms, mas accurate. So, pag lumagpas na tayo dun sa saturation pressure, pero we're still below the critical pressure, instead of yung 2 terms na virial equation, gamitin na natin yung 3 terms, mas excellent yung results. So, ito na yung itsura niya, yung meron ng third term. Ito, nadagdag. So, it can be solved directly for pressure. Okay? Pero, cubic siya in volume. So, if, for example, yung volume yung gusto nating ma-solve, iterative yung approach natin. So, yung, ano naman sa natin kukunin tong third virial coefficient? Well, it depends on the gas. So, depende rin yan sa gas and sa temperature. Pero, mas less yung data na meron tayo. Unlike yung B, marami tayong experimental data dyan. Yung C, mas less yung data natin about yung on C. Although, meron pa rin naman, meron tayong data ng C found in literature. Yan, effect of temperature on the virial coefficients B and C. So, ito ay ito sa sa ilalim ay meron tayo nung temperature in kelvins. And then sa left side, ito yung value ng B. Sa right side, yung value ng C. Okay, B and C. Okay. Ano yung effect ng temperature? So, sa B, B increases monotonically with temperature. Ayan siya. Diba? This is increasing temperature pag ganon. Nag-i-increase din yung value ng B. Itong curve na to, yung nasa ilalim na curve, yun ay curve ng B. So, yan, B yan. Ito yung curve ng C. Pero, at the temperature much higher than shown, so may limit. Meron siyang na-approach na maximum value. Ito yon. Tapos, hindi na siya, hindi na pinakita. Okay, pero, reaches a maximum value, then slowly decreases. Hindi na kita. Yung C naman, mas mahirap establish yung relationship with temperature. Pero, negative siya at low temperatures, then passes through maximum temperature near the critical. So, ito yon. So, and then, nag-decrease siya with increasing T. So, yun naman ang behavior ng C. Okay, so doon nagtatapos yung special highlight lecture natin for virial coefficient, for the virial equation of state.